On a warm spring day in the American Midwest, life goes on as usual. But just over the horizon, massive thunderstorms are brewing. Within hours, these storms could unleash one of the costliest weather hazards in the United States. Each year, hail causes more than $10 billion in damage across the US, smashing car windows, shredding roofs, and devastating crops. Some years, losses soar past 35 billion. Yet, despite its destructive power, hail remains one of the least understood severe weather threats. Earlier in 2025, scientists launched the largest hail research campaign in over 4 decades, Project ICECHIP. What a great name. The in situ collaborative experiment for the collection of hail in the plains. ICECHIP is definitely a better name. For 6 weeks, more than 70 researchers from the US and abroad chased storms across the Central Plains and the Front Range of the Rockies. Project IceChip centered on five major questions. First, how do hailstones grow, tumble, melt, and travel inside a storm? Second, what storm environments favor large, damaging hail? Third, how can we use radar better to detect and track hail? Fourth, how do hailstone properties connect to the damage that they cause? And finally, how might climate change affect future hailstorms? Unlike tornadoes or hurricanes, hail doesn't make headlines as often, but it is the most consistently damaging thunderstorm hazard in the US. Insurance companies, farmers, and homeowners all pay the price. By studying hailstones in real time, IceChip hopes to improve radar detection, understand how hail grows inside storms, and reduce long term damage through smarter materials and construction. The IceChip campaign used cutting edge tools, mobile Doppler radars scanning storm structure, drones, like the University of Colorado's Raven aircraft, flew behind some supercells to map hail swaths and measure atmospheric conditions. Weather balloons were capturing wind, humidity, and temperature profiles, and specifically designed funnels. The Supermobile Hail Observatory collected pristine hailstones before they melted. By the end of the project's run, nearly 4,000 hailstones had been collected. Some were as large as softballs, measuring over 5.5 inches across. Each hailstone was weighed, photographed, and even crushed to test the strength. Researchers examined internal layers looking for growth patterns and contaminants like dust or microplastics. These insights could help reveal why some hailstones are brittle while others are dense enough to punch through shingles and siding. So what did hundreds of thousands of dollars and 70 researchers find out? Early discoveries revealed that radar often misidentifies hail, sometimes showing hail where there isn't any, or missing the biggest stones altogether. Researchers also learned that hailstones can vary wildly in density. Some are fragile and shatter on impact, while others are rock hard and capable of punching through roof material. Perhaps most surprisingly, in just one season, the project collected nearly 4,000 hailstones, giving scientists the single largest season of hail datasets in US history. For meteorologists, IceChip is a goldmine. It provides ground truth data to improve radar algorithms, meaning that the forecast of hail size and coverage can become more accurate. It also helps validate storm models so scientists can better understand how hail grows inside powerful updrafts. And in the long run, it contributes to climate research, showing how warming might change the frequency and size of hail events. For ordinary people, the impacts are very real. Better forecasts mean you'll know sooner if a hailstorm is coming, giving you time to move your car, cover crops, or shelter livestock. Insurance companies can use ice chip data to refine risk models, potentially lowering costs. In short, the research isn't just about science, it's about protecting homes, livelihoods, and communities from one of nature's most damaging forces. Early results showed gaps between radar detected hail and what actually hit the ground. This means that forecasters were missing or even overestimating hail impacts. Researchers also found that hail strength varies wildly. Some stones were crumbling easily while others were rock hard, suggesting new testing standards for roofing and construction. As our climate continues to warm, fewer hailstorms are expected, but the ones that do impact us are going to have stronger updrafts, causing even larger hailstones. For researchers, storm chasing comes with inherent risks. Vehicles are going to be dented, windshields cracked, and even some students during the project sustained minor injuries while collecting samples in the field. But the data gathered can prove very useful in future storm predictions. Project ICECHIP is more than just storm chasing. It's a landmark step in hail science. It's going to help improve forecasts, strengthen our homes, and help us adapt to our changing climate. For the first time in decades, hail is no longer just a costly mystery. It's a problem that we can start to solve.